Right, I want us to look at how they set functions in graphs. This is a typical example. I think this is November 2008. It was question 4 during that year. I want us to look at it. This is our second example. We're given two functions here, the one of h and the one of f. When you look at these two functions, you must clearly see which graph. Look at the first one, x peso. Therefore, it's an exponential graph. Look at the second one. The second one, x will be squared. It is the parabola or the quadratic function. But siyazi ukuthi quadratic function here can come in three ways. It can simply come in the form y is equal to ax squared plus bx plus c equal to 0, which we are used to. Or it can come into y is equals to a into x minus p all squared plus q, or y is equals to a into x minus x1 into x minus x2. This is when you are given these two coordinates as the coordinates of the turning point. Kumuluguti parabola yethu, if it's positive, if they are phezulu, if we are given it in this form, as in the second one and the third one, if we are given it in this form, we'll definitely be given these coordinates of this point, where p will be x of the turning point and q will be y of the turning point. So I can see this graph straight away we can see the coordinates of the turning point. In this particular case, x turning point will be 1, y turning point will be minus 8. It is not minus 1 x turning point, but this is 1 because it's x minus than p. P o x, u minus p. So we should take note of that. Right. I wanted to do as we are required to do. So I would like to start with which one is easier to do there? Which one is easier to do? The exponential graph. Let me start with the exponential graph. Yes. Let me sketch the exponential graph. Number one, it is not a fraction, and this exponent is positive. Therefore, it is an increasing function. So to sketch it, 2.1, I've got to sketch this graph. We'll look at the second one. Minus 8. Maybe let me start with the parabola. What do I have there? I have this minus 8, which is my turning point. It is down. Gidinga amapoint amathathu. Gidinga y-intercept, gidinga my x-intercept, gidinga a turning point. Already I do know the turning point. I know my turning point. What are the coordinates of the turning point? X, U1. U1, y turning point. That is the y of turning point, which is minus 8. So second turning point, sengishoda ngawo 2. Imaphi amabili na ngishoda ngawo? Y-intercept kanye nani ne-x-intercept. How do I find the y-intercept? Uma ngifuna i-y-intercept, ngenza u-x abe u-0. That's all that I need to do. I've got to make, in this graph, I've got to make x abe u-0. So I do have one point that I need. So if I'm looking for y-intercept, so my y would be equals to this number 2 into, sengenza bani manje 0. Ngenza u-x abe u-0 because I'm looking for the y-intercept. It's going to be 0 minus 1 all squared minus 8. So my y-intercept will be, what do I have there? What is 0 minus 1? It is minus 1. Square that, it will be positive 1. What is 1 times 2? It is 2. 2 minus 8, it is minus 6. So the y-intercept will be minus 6. So I do have the y-intercept now. Saying now your turning point, now y-intercept. In short, again, the x-intercept. How do I find the x-intercept? Whenever I'm looking for the x-intercept, I make y equal to 0. So you go to the graph that you have. You've got to make y equal to 0. What is it that I have? I've got y is equals to 2 into x minus 1 all squared minus 8. Remember that I'm looking for the x-intercept. Mangifuna x-intercept senza y abe u-0 iqanda. This is 0 is equals to 2 into x minus 1 all squared minus 8. That's what we have. Remember, sifuna x thina. Remember ukuthi yini le futhi, it's a quadratic function. Ukuthi soba no x abangaki aba 2. Ama roots ethu mabili, 2 x-intercepts. All right. Let's do this thing. So let's break this one. Let's break this bracket. So 0 will be equals to, what is, you're squaring a binomial here. What is x times x? X squared. Times 2, it's 2x squared. What is x times minus 1? It's minus x, double that, minus 2x times 2, it's going to be minus 4x. What is minus 1 times minus 1? It is 1 times 2, it's plus 2, then minus 8. Remember, this is going to give me the equation. Right, let's move on. Remember that in my equation, I know the y-intercept already. It is minus 6. Let's do this thing. That's nobody much. So 0 is equals to 2x squared. Maybe let me just clean it. Let me just clean it right so that we'll see exactly what is it that we have. We will have, let's write it in the correct way. We're going to have 2x squared. I'm taking everything inside and everything that side. Minus 4x plus 2. What is plus 2 minus 8? It is minus 6. So let me not just waste your time here. It's going to be minus 6. Right. This is equals to nothing. 0. That is equals to 0. What else do we do now? We factorize. What is the first step when you factorize? The first thing that you need to do when you factorize is to use your eyes and look for a common factor. A common factor is something that is common in all those three terms. Remember, we've got 3 terms. This is a trinomial. 1, 2, 3. It's an algebraic expression. Ama-terms mathathu asinawo lapha ya. Siyayibona inamba ekhona la, nala, nala. Leyo namba ekhona kundawo zonke ubani? U2. So we divide everything by 2. Both the left-hand side as well as the right-hand side. If you divide this by 2, you are left with x squared. You divide this by 2, you are left with minus 2x. You divide this by 2, you are left with minus 3. You divide that by 2, you are left with 0. Because 2 does not go to 0 times. So that's what we have. That's what we wanted to have. Now we can factorize. We open 2 sets of brackets. Remember, this is 0. What do I have now? I've got x times x. That will give me x squared. What are the factors of 3 that will give me minus 2? I know that the other one must be 3. The other one must be 1. How do I get minus 2? This one must be negative, and the smaller number must be positive. Right. What is it that we have here? We're multiplying 2 numbers is capital 0. Simply means that one of them might be 0. It can be this one that is 0 or that other one. If this one, x minus 3, can be 0, or x plus 1 must be 0. So solve this side. X then is equals to 3, or x is equals to minus 1. These are the roots that we have. These are the 2 x-intercepts. Right. Let's see what we have now. We do have the turning point. We do have the y-intercept. We do have the roots. These are the main 3 points that we needed. You need the y-intercept, you need the 2 x-intercepts, and you need the turning point. Then we can sketch the graph. I see domain the graph. Let's enjoy it while we are sketching it. Remember, I look at my points. Fortunately, exam has a diagram sheet where you sketch these graphs. If not given, you can sketch it yourself. We've got a y-intercept that is minus 6. Let's check the turning point. Oh, the turning point is minus 8. Check my roots, 3 and minus 1. So I need more negative along the y's. So the y-axis must be bigger than the x-axis. The negative ones must be bigger. The positive x must also be bigger, so I can sketch it in this form. So I know that my graph will be somewhere below. All right. When I plan my graph, I know that the biggest number of the value of y that I will need is minus 8, which is the what? The minimum value in this case. Yes, the minimum value. Right. This is 1. Okay, let me have it in 2s. This is 2, 4, 6, 8. Right. This is 2, 4, 6, 8. This is minus 2, minus 4, minus 6, and minus 8. Right. Maybe I take a few there. This is 2, 4. This is 2, 4. Remember, these are the y-axis, and these are the x-axis. All right. How many numbers do I need? The biggest is 3. On the negative side, I just need minus 1. Let's do this thing. This is 1, 2, 3. Make sure that these spaces are the same. This is 1, 2. Because I just need minus 1 this side. This is minus 2. This is minus 1. Put the values that side. It's 1, positive 2, and positive 3. Try and make the spaces to be the same. You can use your ruler. All right. Once I have my Cartesian plane okay, I can go and plot those points. Take them from paper and put them into my graph. Let's start with the y-intercept. What is the y-intercept that we got? The y-intercept was minus 6. I go to minus 6. I don't go there. I go to y, minus 6. This is my point. I make a mark there. It's an important point there. What is the next point that I need to write? I need to plot there, put the x-intercepts. What were my x-intercept? One x was 3, the other one was minus 1. Minus 1, make sure that you put it on the right place. Minus 1 as well as 3. The next point, this is the turning point. Like your x, no y. Simbiza ngani x turning point. Simbiza ngani axis of symmetry. Yenza an axis of symmetry graph it cut into two equal parts. So we know that u1 lo, x turning point, esingambiza axis of symmetry. Minus 8, y turning point. In this case, or minimum value of a. Let's start with x, or axis of symmetry. This is called the axis of symmetry. It should cut at 1. Right. What is the value of the y there? Y is minus 8. So where the 2 meet will be my point. This is minus 8. Well, with these two, so the coordinates of here, x ubani. You look up, it's minus 1. It's positive 1, not minus 1. And do y ubani, you look this side, it is minus 8. So these are the coordinates of the turning point. Now I've got all the points that I need. Remember, the y-intercept, I've got it as 6. The two x-intercepts, or the roots, are minus 1 and 3. And the turning point is 1 is to minus 8. You can check it, it is 1 is to minus 8. All that you need to do now is to sketch the graph. Make sure that it has got smooth curves. Right. Like this one, let's try and make it look good. It goes up to infinity. Right. What is the name of this graph? It was given as graph of f. So this is a typical graph of f. Right. I name it. I give it its name. It is called the graph of f. Right. How many points would I get for this one? 8 marks for nothing. Just sketching the parabola. Just 3 points, 3 points. The first one, the y-intercept. The second one, the 2x-intercept. The third one is the turning point. Then you join those points, you got your 8 marks, which is quite a sizable number of marks. Right. Let's look at the next question. We're required to sketch these two graphs, sketch both graphs on the same system of axis. Okay. Maybe the next one will be 2 marks if we give this one 6 marks. Right. What is the next graph? This one. We're sketching this graph now. They said we must sketch it on the same system of axes, meaning that you don't have to draw another Cartesian plane, draw it there. Okay, let's find our points. We know that this is an exponential graph. If we make x equals to 0 there, what will be y? Because any number to the power 0 is 1. So we've got the coordinates here of 1. 1. What are the coordinates here? X uban lapaya, u0, y uban u1. We definitely know that one. Since our x is positive, it will be an increasing function, and the number is not a fraction, we know that it will increase. So we know the next point. If I put my x as 1, if my x is 1, what will be y? It will be 4 to the power 1, which is 4. So if my x is 1, y would be 4. It will be somewhere there. Y is 4, x is 1. So this will be another point. X u1, y u1, u4. I join the 2 points and make sure that it does not touch this x asymptote that is here. So it will be a graph like this one. Remember when I sketch it, it should go like that one. It should go exponentially. It should not be a hyperbola, exponential graph. What is the name given to that graph? It was given as h. Name your graph. This is the graph of h. So the examiner can see that this is f and this is h. So that's how you sketch those two graphs. Let's look at the next question. 2.2. This was 2.1. Now I want us to do 2.2. Without any further calculations, sketch the graph of g, which is the same as y is equals to log x to base 4. They're bringing the log graphs now. This is a log graph, and we know that a log is the inverse of the exponential graph. So it is the inverse of the graph that we've just sketched. All that we need to do is to plot the inverse points, then join them. Look here. If this point was here in the original graph, in the log graph, it will be 1 is to 0. Where is that point? 1 is to 0. X is 1, y is 0. So this is the point. So this is the point, 1 is to 0. So I've got this point, any inverse here. What will be the other point? Let me just sketch the graph so that you'll see how easy it is. Look at this one. From this point, where do I go? I go towards the negative x-axis. So from this point, I will have to go towards the negative y-axis. So I'll be going this way, negative y-axis. I don't touch this one. Where do I go from this one? I will just complete my graph. That is the graph, which is the log graph, which is the inverse of the exponential graph. Remember that since I've got this point here, I've got to push this other point there as well. So this point will be 4 is to 1. This is another point that is important. What graph? What do we call this? Sketch the graph of G. So that graph is called G. Now, you name it. This is the graph of G. I've got all 3 graphs, then I'll be getting all 8 marks. Remember, this is the exponential graph, which we refer to as H. This is the quadratic graph, which we call it F. And the last one was the log graph, which was the inverse of the exponential graph. Right. Remember that we've just finished 2.2. I'll just write it here. This was 2.2. This was 2.1, the first one that we sketched, the 2 graphs. Then I have to look at 2.3. In 2.3, we're required to find the graph of f is shifted 2 units to the left. To the left, it's this side. If I'm facing that side, this is my left. Write down the equation of the new graph. So this graph of f, which one is the graph of f first? This is the graph of f. This is the graph of f, which is what? The quadratic graph or the parabola. They are saying this graph, let's look at it, it is shifted how many units? 2 units. Where? To the right or to the left? It is shifted to the left. It was not shifted up or down, just to the left. What happens? It will only affect OX because it is the X movement. Now, when we look at, let's look at our graph. I'm going to do it here. Our graph that we have is y is equals to 2 into x minus 1 all squared minus 8. This is the graph that we're talking about before it was shifted by this instruction. Now they are saying this graph must be shifted by 2 units to the left. Now when we move a graph to the left, it's here, we're moving it to the left. Whenever you move the graph to the left, you add. When you move the graph to the right, you subtract. As you see here, it's minus. It means that this graph was here. It was shifted 1 unit to the right. That's why we've got negative there. So when we shift it to the left, we've got to add. Let's do that. So this graph here, x or ediwe, x onyakazile, akanyakazanga ubani y. So the turning point, this graph did not move up or down. It remained like this. All the it's the movement this way. But x, y is not changing. It's not changing. X. If we run the graph of f is shifted 2 units to the left, write down the equation of the new graph. We know that in the new graph, something is not going to change. What is it that is not going to change? The minimum value. This graph will always be here because I'm shifting it like this. So y is not going to change. It's still going to be minus 8. I know that one. So this value here is not going to change. What is it that's going to change is the value of x because I'll be moving it from this position 2 units to the left. Let's do it off by heart. The graph is here. I'm moving it 2 units. Do you understand that? Let's move it. From here to here, I've moved it how many units? 1. So the turning point will be somewhere here at minus 1. Let's check it. Let's check it. So this will be y is equals to 2 into x minus 1. Let's shift it now. By how many units? By 2 units. Where? To the left. When we shift it to the left, what do we do? So we're shifting it by 2 units to the left. Let's do that. So we're shifting it by 2 units. This tells me I'm shifting it to the left. This is all squared minus 8. I know this does not change. What is it that I have there? So my graph would, remember it is the very same graph. The only thing that will change is the x-intercept. I mean the x-asymptote. Let's do it. It is y is equals to 2 into x. You work this 2. 2 minus 1, it will be plus 1 now. All squared minus 8. Remember, if it is plus 1, it shift left by 1 unit. So basically the new graph will be turning here. This graph will be turning here. It will be the same graph as this one. It's only that it will be turning here and going up. This one will be here. This point will be here. The graph will be shifted by just, 2 units. So if it was here, it will shift by 2 units to the left. So it will cut now here at minus 3. Right, that is what we mean by shifting the graph. So the solution for the third question is this one. So this will be the new equation of the graph. Write down the equation of the new graph. So the equation of the new graph will be y is equal to 2 into x plus 1 all squared minus 8. Thank you.